Hi everyone, welcome back to my channel. In this video, I am going to solve Surface Chemistry CSIR NET previous year questions from 2014, and also I have mentioned 2011, 12 and 13 video link I have mentioned in description. Please go through that. Now let's move to the question. Question 1. This is asked in CSIR NET June 2014. Question is, generally hydrophobic colloids are flocculated efficiently by ions of opposite type and high charge number. This is consistent with the four options given. Option A, peptidization principle. Option B, Kraft theory. Option C, Hardy-Schauffele rule. And option D, Langmuir adsorption mechanism. Now, let's see the solution. For this question, the correct answer is Hardy-Schauffele rule. The Hardy-Schauffele rule states that the coagulating or flocculating power of an electrolyte increases with the valency of an ion having a charge opposite to that of the colloidal particle. So, hydrophobic colloids are flocculated most effectively by oppositely charged ions with the higher charge numbers. For example, a negatively charged sol is coagulated more effectively by here Al3 plus greater than Ba2 plus greater than Na plus. So PO4 3 minus greater than SO4 2 minus greater than Cl minus. Therefore, the statement in the question is explained by the Hardy-Schauffele rule. So the correct answer is Hardy-Schauffele rule. Option C is the correct one. Now, let's move to the second question. This also asked in CSIR NET June 2014. For the non-dissociative Langmuir type adsorption of a gas on a solid surface at a particular temperature, the fraction of surface coverage is 0.6 at 30 bar. The Langmuir isotherm constant in bar per unit at this temperature is four options given. Option A 0.05, option B 0.20, option C 2, option D 5. Now let's see the solution. For Langmuir adsorption isotherm, formula is theta is equal to Kp divided by 1 plus Kp, where theta is equal to fraction of surface coverage, that is equal to 0.6 that I have given in question, and P is equal to pressure, that is equal to 30 bar, and K is equal to Langmuir constant, that to be we have to found. Now substitute the values. Theta is 0.6 is equal to 30k divided by 1 plus 30k. So cross multiply 0.6 into 1 plus 30k, that is equal to 30k. 0.6 plus 18k is equal to 30k. So 12k is equal to 0.6. K is equal to 0.6 divided by 12. That is equal to 0.05 per bar. So the correct answer is option A, 0.05 per bar. Question 3. This was asked in CSIR in December 2014. For a polydispersed macromolecular colloid, osmometry gives here four options given: weight, average molecular weight, number, average molecular weight. Option C, both weight average and number average molecular weights. And option D is viscosity average molecular weight. Now let's see the solution. For this question, the correct answer is number average molecular weight explanation. Will number average molecular weight is the correct answer for this question. Now we'll see the explanation. For a polydispersed macromolecular colloid, osmometry measures the osmotic pressure, which is a colligative property. So colligative properties depend on the number of solid particles, not on their size. So, the osmotic pressure equation is pi is equal to CRT divided by Mn, where pi is equal to osmotic pressure, C is concentration, and R is gas constant, and T is equal to temperature, and Mn is equal to number average molecular weight. Thus, osmometry directly gives the number average molecular weight Mn. So the correct answer is option B, number average molecular weight. Now, other methods for comparison. This remember these methods because this will be useful for other questions, similar kind of questions. Osmometry, that always gives number average molecular weight Mn, and light scattering, that gives weight average molecular weight Mw. Viscometry is viscosity average molecular weight. Understood? Now let's move to the fourth question. This has asked in CSIR in December 2014. Question is, among the following figures, the variations of mass adsorbed with pressure for a monolayer and a multilayer are represented by mass absorbed in versus pressure. Here, three types of graph given, A, B, C. Four options given, A and C respectively. Option B is A and B respectively. Option C is C and A respectively. And option D is B and A respectively. Now, let's see the solution. For this question, A and B respectively is the correct one. Now we'll see the explanation. For a monolayer adsorption, that is called Langmuir isotherm. In monolayer adsorption, adsorption increases rapidly at first and then reaches a constant value, that is saturation, because only one layer of molecules can be adsorbed. Thus, graph levels of plateau at high pressure. Here, graph A shows this behavior. Next is multilayer adsorption, that is PET isotherm. In multilayer adsorption, after the first layer is completed, additional layers continue to form. Therefore, adsorption does not remain constant at higher pressure. It increases again due to multilayer formation. This graph B represents this behavior. Therefore, for monolayer adsorption corresponds to graph A and multilayer absorption corresponds to graph B. Therefore, the answer is option B. A and B is the correct one. I hope you understood this concept. If you like this video, please like, share and subscribe to my channel. In next video, I will come with some more previous year questions. Thank you. Have a good day.